Today we are going to be talking about decimal place value. We've already talked about the place value of whole numbers. We're going to start today talking about the place value of decimals. This is really a cool time because decimals have a super secret math trick to it. So be listening for this super secret math trick in this video. Go ahead and open your notebook, open up to the table of contents. This is number 3 in your table of contents. And you're going to write decimal place value. Then you're going to turn to your next fresh and clean new page with the holes on the left hand side, and you're going to title it decimal place value, just like we put in our table of contents. Our I can statement today is I can tell the place value, name, and worth of decimals. The worth means how much they're valued at. The other day I talked about how 7 and 9, of course, 9 is bigger than 7, but if it's in the wrong place value, 7 could be worth more, like 700,000 compared to just 9 in the one's place value. Excuse me, some new vocab words. We're going to have whole numbers. Oh wait, that's not new. You should have written it the past 2 times that we wrote notes. Whole numbers are a number that is the complete set of something. So we're going to add decimal number to that. And when we have a decimal, it's part of a whole. It's like I had a whole pizza, and then I chopped it up into little pieces. They're part of a whole. Go ahead and pause this if you need more time to get it written down. That's cool. Just make sure that you're not staring off into space. You need to go ahead and get this written down and move on to the next part. Okay. So we're ready. We've got all of our information. We have whole numbers. We have decimal numbers. We know what they are. Here's the decimal number that I'm giving you. I have 3 and 1,459 10,000ths. When we say a decimal, we start with the number that's in front of the decimal. This decimal right here now becomes and. We don't say 3 point. We say 3 and. Then this number back here we say as an independent number. If this part was all gone, how would you say this number? We see 1,459, and then we say the place value that it's in. And for decimals, we have, we could keep going with the place values. If you look up at my board, I have the place values further down the line. The tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions. And they all have this TH on the end of them to show you that they are not over here in the whole number side. They are on the decimal side. So you need to get this written down and make sure you label tenths, hundreds, thousands, 10,000s. And even as an adult today, I have to repeat those in my head. I usually use my fingers to know, okay, I'm at the decimal point, and then it goes tenths, hundreds, thousands, 10,000s. And we'll practice this at the table a little bit so that we can nail whichever place value we're in. So I drew a little picture here too. You guys are writing the notes on this. You're getting the chart down. This indicates 3 holes. So these are my 3 whole pizzas. And then I have my decimal, and all the numbers that are behind the decimal are parts of the whole. So there's 3 holes and some extra. That's what the decimal indicates. And some extra. Get this part written down and be ready for the next part. Alright, so we have our whole number again showing you tenths, hundreds, thousands, 10,000ths. I wanted to show you what the breakdown was. So if you're thinking about these pieces, the further you get out, man, this must be a really big number because it's 1,459 10,000ths. Here's what it looks like. 10 tenths, 10 of these guys will equal 1 whole. So I need 10 of these to make 1 whole. If I get to 9 and I add another tenth, it's gonna move over to make 1 whole. I need 10 of these hundredths to make 1 tenth. Not 10, I need 10 of these to make 1. So I have 4. I'm less than half away from 1 full tenth. So the more numbers behind the decimal does not equal a bigger number. It just helps us to know the place value of it. So the 9 in this number is in the 10,000ths place value. The 4 is in the hundredths place value. The 3 is 3 wholes. We need to know the word equivalent. Equivalent means the same amount. A good synonym for equivalent is equal. They use equivalent when we are trying to find like equivalent fractions, or we use the equal sign in a lot of math problems. Equivalent we're going to use with decimals because we need to know what decimals are equivalent. Notice I have an equal sign here. This is that super secret math trick I was talking about earlier, this 0. You'll notice that each one of these numbers, even though they look different, they are the exact same. They mean the same thing. In this one we have 9/10. It's 4 and 9/10. It's the same thing as 4 and 90/100ths. Is the same thing as 4 and 900,000ths. So the super secret math trick is that we can add zeros onto the end of whatever decimal we have. So for instance, if I start with 109, I can keep adding zeros on the end of there and it does not change the value of the number. Now if I were to take away this 9 that was on there before, that would change the value of the number. Or if I added a 0 and then a 1, that would change the value of the number. But I can do this. I can add as many zeros as I want on the end of the number, and it is not going to change the value of the number. It might change how we say it, but it won't change how much it's worth. That is true. So if you see a number that's like 3.90, or said 3 and 90/100ths, we can simplify things by taking that 0 off. We don't have to have those extra zeros if it's just a 0 at the end. Decimals can be written in similar forms as whole numbers. So we have standard form notation, we have expanded form notation, we have word form notation, and I'm going to talk about each of these, how we would write them as decimals. So our standard form is just going to be plain numbers. I'm going to write it out like this, and I would say this number 7 and 65,713 tens, hundreds, thousands, 10,000s, 100,000s. See, I have to count every single time. I have to know my place values: tenths, hundreds, thousands, 10,000s, 100,000s. Tenths, hundreds, thousands, 10,000s, 100,000s, tenths, hundreds, thousands, tenths, hundreds, thousands. Down here we're going to do expanded form, or expanded notation. This is where we take each one of these numbers and we expand it out so we know the value of it. So this 7 is worth 7. It's in the 1 spot. It's a whole number. It's worth 7 items. That 6 is worth 6/10, so I write it as 6/10. That 5 is worth 5/100ths, so I write it as 5/100ths. The 7 is worth 7,000ths, so I write it as 7,000ths. The 1 is worth 1/10,000ths, so I write it as 1/10,000ths. The 3 is worth 300,000ths, so I write it like that. 300,000ths. I could also show it in a fraction representation, because this is 6/10, which is the same thing as this fraction, 6/10, or 6/10. This is 5/100ths. This is 7,000ths. This is 1/10,000ths. This is 300,000ths. These two things are written the same. This is just decimal form. This is fraction form, because fractions and decimals mean the same thing, part of a whole. Down here, word form or word notation. 7 and, this is the decimal, 65,713 100,000ths is how we would say that. So, once you have watched the video, you have done the notes. You need to move on over to the class kick. Class kick code will be get logged on and get logged into there and start working. This is your assignment today. It will take a grade off of it. You should also be recording your clues for your secret letter or your secret number. Your secret number, your clue today is there is a 3 in the thousand spot. There's a 3 in the thousand spot. All right, go ahead and take care of business. And as always, happy mathing.